All right, this is part 2 of activity 4. For this question, it says line DB and EC intersect at point F if the measure of angle BFC is 44 degrees. So BFC, this right here, is going to be 44 degrees. And then it says angle AFB. So AFB, this right here, is going to be 61 degrees. And then it's asking you for these 3 right here. So let's start with this first one. So this first one right here says the measure of angle AFC. AFC. So I want this whole thing right here. This whole thing. That right there, to get this one, you're going to notice is that it has these 2 angles inside of it. So to get this whole thing, I'm just going to take those 2 angles and add them to each other. So we have 61 plus 44. And that's going to be 105 degrees. Okay. Next one, AFE. This one says AFE. Okay, AFE. Now, let's remember all of the other angle pairs that we've talked about thus far. These right here, we have adjacent angles. Adjacent angles are angles that share a side and a vertex. AZB and BCZ are adjacent angles. Linear pairs, 2 adjacent angles whose measures add up to 180. Complementary, 2 angles whose measures add up to 90. We have supplementary, 2 angles whose measures add up to 180. And vertical, 2 angles formed by intersecting lines that are congruent and non-adjacent. It looks like this. Okay. Now, if you're wondering where this is located, this is on page number 5 in your notebook. I gave you time in class to copy it. Some of you had time, some of you didn't. So it is here if you want to copy it into page number 5 so you can have it in your notebook. But this should hopefully look familiar. This is a little cheat sheet that I gave you over angles inside of your notebook or your composition vocabulary notebook as well, okay? So this should look familiar, okay? Now, real quick with this type of question right here. If you look at it, there really isn't not a lot of information that I do have to get that one right here. So before I start with this one, let me maybe do something that's a little bit easier, okay? Now, I do just want to talk about vertical angles really quick. Now, vertical angles was this last one right here. In class, we talked about that vertical angles were formed by 2 intersecting lines. And I mentioned to you that we were going to work with this later. They are congruent. Okay? Now, when they are congruent, remember congruent means equal measures. So essentially what we're saying is this one and this one right here are the same measure. So if this one right here is 100 degrees, this one right here will also be 100 degrees. Okay? That's the relationship that vertical angles have to each other. So you're going to see that anytime you see 2 lines that are crossing each other, you have vertical angles. So looking at this one, they started off by telling us that lines DB, so this line right here, and line EC, this line right here, those are intersecting. Now, if you're looking at this one, what I do want you to pay attention, you see there's 4 angles. There's this one, there's this one, and this whole thing, number 4 right here, okay? Now, what's really nice about these angles right here is they have that special property that the ones that are vertical angles are congruent. So what that means is look for complementary or vertical angles. I keep saying the wrong thing. Vertical angles. When you're looking at vertical angles, remember they're the ones that are non-adjacent. So the ones that do not share a side. If you look at 2 and 4, these 2 right here, these are vertical angles. What that means is if I tell you that this whole thing right here is 150, this one right here will also be 150. But I don't have the measurement of those. But if you look at angle 1 and 3, that's another pair of vertical angles. And we saw that we have that angle 3 is that 44. that means that this one right here is also 44 degrees. Now, we're going to make a note of that on this side because, just so you can have it for further use or for use in the future. These two right here, and I'm just going to go ahead and label them, are vertical angles. And we're going to make a note for ourselves. They are congruent. Remember, congruent means that they are or they have the same measurement. All right. Now, we do also know that this one right here and this one also have the same value, but again, that wasn't very useful for our questions because I still don't know what this is. So I need to know what both of them are in order to get this one right here. Okay. If you read this last one, it is asking you for angle EFD, which EFD is this one right here. And we just talked about how those two are the same. So that one is 44 degrees. All right, now let's do the one that's missing. A couple of facts about angles. You're going to see that if we're going all the way around, all of these angles right here have to add up to, you see it makes that full rotation, a circle. That is 360 degrees. Now, maybe we didn't know that, and that's fine. So let's instead use something that we do know how to use, and that is linear pairs and supplementary angles, because we kind of talked about, again, when you took your test, how these things are intertwined with each other. Linear pairs are two adjacent angles that add up to 180. So what you're going to see is the reason they're called linear pairs is you have an angle and another angle like this. And I noticed that the bottom part right here made this line right here. These two measured 180 degrees, okay? So let's look back at our picture. So for this middle one, the last one that I'm asking you for, it's AFE, which is this. Now, if I extend right here from E, and I extend it all the way right here, which it is a line because they told me right here, right? This line is called EC. Then I know that whatever this is, with whatever's over here, is going to make a 180 degree angle. Well, I already know what this is. I know that this right here is 105. So that means that this yellow angle right here and this green angle right here, you see they make that T shape? These are linear pairs. These two are going to add up to 180 degrees. So in order to calculate that one that's left over, I would do 180 minus 105. And that's how I would calculate that angle that's missing. So my angle would be 75 degrees. Keep these right here in mind when you're working with angles. Really what makes this section a little bit trickier than segments is not only are we using the angle addition postulate, but we are using all of these other rules that we've already talked about angles. Linear pairs, complementary, supplementary, vertical angles, all of these that we've already talked about, we are going to be using here as well, okay? So just keep that in mind as you're working with your questions. Maybe you're like, well, I don't really have, like, you know, this information, so I can't use angle addition postulate. You can still use all of these rules on page number, again, I forgot, number 5, okay? So have these in your notes. They'll be useful. And anytime we use them, let's make a reference to page number 5 so we can go back and look at them if we're kind of like, what the heck is a vertical angle, okay? We can use that. I'm going to write right here that these are linear pairs as well, okay? And that way when you are studying and you're looking at these questions and you're wondering, well, why did I get 180 or where did you get 180 from? It's because they were linear pairs. That's located on page number 5, okay? You should have that little cheat sheet on or in your vocabulary notebook for your test as well. All right. let's look at this next page. For this one right here, it says, adjacent angles are coplanar angles that share a vertex and a side, but no interior points. In the figure at the right, angle ABD is adjacent to angle DBC. So we talked about this already when we did our test. Adjacent just means next to. Now, congruent figures are angles that have the same measurement. To indicate congruence, you can either write this right here or this right here. Now, let's just kind of talk about what we talked about when we talked about the difference between equal signs and congruency signs, because you're like, those two things look exactly the same. If you look at the one at the top, it does have that measure, that M right there. Remember, equal signs, we're comparing numbers. So for this one, I'm talking about the measurement of ABD. We're talking about a degree. Equals to the measurement of angle DBC. Again, you're talking about a degree. So the measurement is equal to the measurement. Now, remember what congruency meant. Congruency is equal measure. So instead of writing M right here, congruency is looking at just the figure itself. It's, again, just telling you information that this angle and this angle right here have the equal measurement, okay? All right, let's look at this one. The bisector of an angle is a ray that divides the angle into two congruent adjacent angles. Now, bisector, another way that you're going to see it is angle bisector. And it's what cuts it into two congruent adjacent angles. So two congruent adjacent angles. Now, bisector is kind of like the midpoint of the angle. Now, I put midpoint in quotation marks there because midpoint only goes with the segment. But I want you to think of how or what all the properties that we talked about with the midpoint. The fact that it cuts it in half. It cuts it in half so the two pieces are going to be congruent. It cuts it in half so we have that relationship, if you remember on your cheat sheet. Let me pull it up real quick. If you remember your cheat sheet, all those relationships that we talked about before. Okay? This one right here where the two pieces were the same. This one right here where this whole piece was double that of the other pieces right there. Okay? I want you to keep all of those in mind. So for example, if blank bisects angle ABC, the way that you're going to see your things that are bisecting is they're going to be rays, okay? So you see this one, this ray right here. Remember, bisector is the thing that cuts in half. It's the scissor, it's the knife, okay? So we're going to see that this BD is cutting this angle, this whole thing in half. So ray BD is your bisector. So it bisects angle ABC, then ABD is congruent to DBC. Now, you're going to see a symbol right here. If you have a highlighter at home, go ahead and do that. This right here is your arc marks. So I'll mention it again. I'll bring it back to what we were working on before. When you were doing midpoint, we use tick marks. When you're using angle bisectors, you're using arc marks, okay? Sorry, I spelled it wrong there for a second. Now, these arc marks, again, are used in your pictures. So remember for the ones that we did in the first part that you hopefully watched, how you had this angle or this ray that you were drawing in and it wasn't perfectly in the center. Anything with the word angle bisector will be perfectly in the center, okay? So let's look at number 6. Given AH, and I don't know if your copies have this, but mine does. Go ahead and add ray symbol right there at the top. Given ray AH bisects angle MAT, determine the missing measure. So we're going to start by drawing our pictures. Just like we did for segments, we're doing the same thing for angles. So first things first is I draw my angle. The angle is angle MAT. The most important part is for you to have your vertex in the right spot, and then M and T will follow on the other sides like this. And then it says AH bisects. Bisects means to cut in half, okay? So I'm going to just do it in a different color. You don't have to, but I am. Just to remember, okay? and the first one will be the only one that I do that with. And bisect, remember, we did cut in half, just like when you did midpoint, where you added your tick marks, you're going to be adding your arc marks for these, okay? And it tells you what letter to put on that bisector. You are going to put H right here. Okay, it says MAT is 70. So the whole thing, this whole thing right here is 70. And then it says calculate MAH. So I'm looking for this right here. So again, bring it back to midpoint if it's helpful. The whole thing is 70, and it's made up of two pieces that are the same. We can take that 70 and divide it by 2. That piece right here would be 35 degrees. Think back what we did or in segments. And I'm going to color code this. So if you have your highlighters, go ahead and use them, okay? Just like when we did this, when we were doing segments. We said that the whole thing is equal to 2 times the half. But this time we're just working with angles, okay? So the whole thing is a measure of angle MAT equals to 2 times the measure of angle MAH. I'm going to be honest, with angles, you're going to see me color coding a lot more because I would rather have it look like this than have to write out the names of my angles, if I'm being completely honest, okay? Just keep that in mind. You don't have to color code anything, and you don't even have to write your setup if you don't want to, but we did notice that on our tests, our things, sometimes the setups help us avoid making mistakes. All right, this one says, the measure of HAT is 80. Find the measure of MAT. So let's go ahead and draw our angle again. We have an angle MAT. Your bisector is AH, so we put it right there. And then it says HAT. So this right here is going to be 80. And then the question is asking me for MAT. So MAT is the full thing. So just like what we did over here, the relationship is that if this piece right here is 80, I forgot to add them, but remember, just like midpoint, we have that extra step of adding arc marks. So that tells me that that one at the bottom is 80. This one right here is also 80. So in order to get the full thing, I can just do 80 times 2, which is 160 degrees. All right. Now, let's look at some algebra questions right here. And we are going to be doing a cheat sheet just like we did for segment addition, postulate, and segments last class right here, okay? So the first thing that we talked about was the angle addition postulate. Now, let's go ahead and write this one out. And this one's going to take up more room than the other one, okay? So if you want to just wait until I finish writing everything down for you to write yours on your paper, okay? Angle addition postulate, what you're going to see is that you're going to have a ray in between. Now remember, in between is not the same thing as bisector or in the middle, okay? So let me just do ABC, and I'm going to call this one right here D. Okay. When you're doing angle addition postulate, much like segments, you are going to be adding the first piece plus the second piece to get the whole thing. Now, I'm just starting with color coding right now because, like I said, these are a little bit longer to write, but you will need to be able to write these. So the yellow is measure of angle ABD. The red is the measure of angle DBC. And then the blue is the measure of angle ABC. Okay? That right there is the angle addition postulate. My recommendation for you is to at least color code your things. I'm not really asking you to do this format because I do realize that these are a lot longer to write than segments. But I do want you to get into the habit of color coding, or at least looking at these setups right here, being very intentional about picking which formula or which setup, I'm sorry, not formula, you're going to be using. All right, next one that we did was angle bisector. Now with an angle bisector, our picture looks very similar, but not exactly, okay? For this one, we have A, B, and then C. And let's just use T for bisector. I can't use B because I already used it, so I'm just using T. Now, this picture is a little bit different. First of all, you see that rays in the middle. And if it's not that obvious, you're going to add those arc marks. So angle bisectors look like this. Now, with angle bisectors, much like how we did midpoint, remember with segments, we were talking about how the two pieces that were made were the same. So these two pieces right here were the same. So yellow equals to red. All right. Remember what we talked about, or the next thing that we talked about, how in order to find the other one, sometimes you can just take double of it like this. So same thing here. If I want the full thing being this, there's two formulas and you're going to see they're very similar. You multiply it by the pieces. So 2 times either yellow or 2 times red. So yellow is measure of ABT equals to the measure of angle TBC. The full thing is the measure of angle ABC equals to 2 times the yellow, and the yellow is measure of angle ABT. Measure of angle ABC is 2 times the measure of angle TBC. All right, this right here is your cheat sheet. Now, be mindful. If it's not helpful to see all of those letters right there, all of those names, and it would just be better for you to just focus on the color or color coding it, please do that, okay? This is supposed to be helpful. So if you don't find it helpful to write out all of these names for the angles and you would rather just work with colors, that's fine. Remember this one, or this top one right here, boom, is used for all of them. You can use angle addition postulate for all of them. These right here, you can only use for angle bisectors. I'm going to put a star right there, okay? If the question doesn't say angle bisector, you should not be looking at these 3. All right, let's look at this example. QP bisects angle DQL. So we have an angle. This angle is called DQL. And it's being bisected. It's being cut in half by QP. This is what an angle bisector should look like, an angle bisector question. Notice that I cut it in half, and because I cut it in half, we added those arc marks, okay? All right, then if you don't want to label your picture, you don't have to. I would. It says DQP, so DQP, this one right here at the top, is 5x minus 7. And then it says PQL, so PQL is this one right here. PQL is 11 plus 2x. When you're deciding what your setup is, first off, figure out if it's a bisector question. Well, it is. It has bisect. So that's why I can use these. So I can. along with this one right here. Okay, so we can use both of them. So now we're just going to go through our cheat sheet and see which one we're going to use. I'm going to color code it exactly like what I have on my cheat sheet, where you're going to notice the top part for me was yellow. The bottom part for me was red. And the full thing was blue. Then you're just going to ask yourself, just like we did with segments, which piece am I missing? Okay? Which piece am I missing? You see how you have the yellow. So I have yellow. And you see how you have red. So we have red. And we don't have blue. You see, I don't know what that is. So we don't have blue. Don't have blue. Don't have blue. The only one that's left is this one right here. Now take a look at how they set it up. Yellow in our picture is ABT. In your picture, it's DQP. That's what they did right here. Equals to, then the red. Red is PQL. PQL, that's what they did right here. That's how they got their setup for this question. Okay? So as you're working on these examples, that's how you're going to be doing your setup, just like segment addition postulate. I would go ahead and color code it and make sure that you have, or that you can read this and decide which one you're going to use, just like we did in activity for part 1. Okay? Now, I'm just going to solve this one really quick right here for you if you need more algebra. After they did their setup, they substituted with what each of them is. DQP is 5x, that's why they put 5x here. And PQL was 11 plus 2x, that's why they put that right there. Okay? Then after they substituted, they wanted to get x by itself, so they subtracted 2x on both sides. When I did that, we brought that the 11. 5 minus 2 is 3x. Bring down the minus 7. Then we wanted to get rid of that minus 7 by adding 7 to both sides. That gave me 18, and then I divided by 3 on both sides to get x equals to 6. Okay? Now, read your questions carefully. If I'm just asking you for x, we would be done. X equals to 6. But this one says determine the measure of angle DQL. So we're going to take that 6, and we're going to put it right here on DQL. Now, if you're like, wait, I don't have DQL. Like, this is PQL and this is DQP, so what am I supposed to do? DQL is the whole thing. That's what that question wants. So I want the whole thing. So what you're going to do is you're going to take this and you're going to substitute it into the pieces, okay? Now, you don't have to do both of them like they did. You see they substituted into DQP, and then they took that 6 and did it into PQL, and then they got 23 and 23, and then they were like, okay, well, if they're both 23, that means that the full thing is going to be when you add 23 and 23 together, which is 46 degrees, okay? So the measure of angle DQL is 46. You don't really have to do all that work. It would be nice for you to do it because it allows you to check your work. If you did it correctly, both of them would equal the same thing, which they did. They both equal 23. But really, you just have to do one of them and just take that number and multiply it by 2 to get that 46. Okay? All right, let's take a look at these right here. FL bisects angle AFM. So for this one, we have FL is bisecting, and the picture for all of these is going to be exactly the same. So I am just going to go ahead and draw one picture. One go, and then just copy it to all of them. So AFM is bisected by FL. Remember, bisected means that you're going to add those arc marks. Okay. All right. It says, for A, it says LFM. So LFM, so this bottom piece right here is 11x plus 4. And I know the pictures are a little bit uglier than segments for sure. The angle AFL is 12x minus 2. So AFL, so this AFL is this top one, is 12x minus 2. Okay. To figure out your setup, go and look at your cheat sheet. Now, I'm going to just put it over here for us to use. Ooh. And we can decide what we're going to be using. Now, for this one right here, we do we're going to color code it just to make it easier on ours. You're going to see really when I'm doing mine that I'm not going to write the statements too much for these. They are pretty lengthy and we're in a time crunch most of the time. So I'm just going to color code everything. So I'm going to start with my top piece. My top piece is yellow and I have it. Then my bottom piece, for me, my bottom piece was reds and I have it. And then the whole thing is blue, but I don't have it, okay? So if you don't have blue, I'm not even going to write it down because I don't have it. So we're just going to be looking for something that does not have blue in it. This one has blue, blue, blue. This right here is our setup. Yellow is equal to red. And then just substitute. You can write out the actual formulas if you want. Again, because of time, I'm not going to. Yellow is going to be 12x minus 2. Red is 11x plus 4. And now we're just going to go ahead and solve for x. So when I'm solving for x for this one, we're going to go ahead and get x to one side. So minus 11x on both sides. X, bring that down, bring the minus 2 down, bring the 4 down. I want x by itself, so I'm going to get rid of that minus 2 by adding 2 to both sides. That gives me x equals 6. For this one, it is asking me for the length, or the measure, of angle LFM. LFM is this first one right here, so you're going to take that 6, put it right there, and actually should have gone the other way, here. So for this angle right here, measure of angle LFM, 11, instead of x, we're writing 6 plus 4. So we have 11 times 6, which is 66, plus 4, that is 70. And then it says to do the measure of angle AFM. Now, go back to your picture. LFM is going to be 70. So this part right here is 70. And think of your rules. AFL, I know I didn't do it, but if I really wanted to check, and sorry, I just realized I put it on the wrong one. If I really wanted to check my answer, I could have also put in AFL, and then I would have seen if I did it correctly or not. So I could have done 12 times 6 right here, and then minus 2. Whoops. What you're going to see is that if I did it properly, it should be 70, just like the other one. 12 times 6 is 72, minus 2 is 70. So I know that this one was also 70. Now, for this question, it is asking me for the full thing. The full thing is AFM, so the full thing, in order to get that, I get that 70 and that 70, add them together, and that would be 140 degrees. All right, B. AFM, so the whole thing is 6x minus 2. And you can color code your things as you go if it'll make it easier. AFL, so AFL is this piece right here. And again, my top piece is always yellow, so I'm going to go ahead and label it yellow. And that is 4x minus 10. Okay. Alrighty. let's go ahead and do our setup for this one. So again, bring your cheat sheet out. If I notice for this one, I have yellow and blue, no red. So we're looking for something that does not have red in it. So the first one has red in it. We're not doing that one. The second one has red in it. And the last one has red in it. This right here is going to be our setup. Blue equals to 2 times yellow. Blue equals to 2 times yellow. So we have blue. Again, your cheat sheet can look completely different, okay? So whatever you decided to do on your cheat sheet, do that for yours. So minus 6x minus 2 equals to 2 times yellow, which is 4x minus 10. Then we're going to solve for this one. First step, distribute. 2 times 4, 8x minus 20. Okay, next step is going to be for you to get your x on one side. So minus 6x on both sides. That would give us, and I'm running out of room, so I'm going up here. Negative 2 equals to 8 minus 6 is going to be 2x minus 20. I'm going to get rid of that minus 20 by adding 20 on both sides. When I do that, negative 2 plus 20 is 18 equals to 2x. Divide by 2 on both sides, x equals to 9. All right, LFM is what this question is asking me for. LFM. So LFM is this one right here. But I don't have that one. But keep in mind what we're doing bisector. Bisector means that these two pieces are the same. So we are going to take that 9 and put it into AFL. So we have 4 times 9 minus 10. So 4 times 9 is 36. 36 minus 10 is 26. 26 right here. You can always check your work. Remember, AFM is the whole thing. So if I did it correctly, if this is 26 and this is 26, that means that the whole thing should be 52. I mean, you can check it. 6 times 9 is going to be 54. 54 minus 2 is 52, which is what we were looking for. So we did do it correctly. All right, number 7. Angle A and angle B are complementary. Measure of angle A is 3x plus 7, and measure of angle B is 6x plus 10. Determine the measure of each angle. Sometimes there's going to be something like this, and you're going to be like, okay, well, they didn't give me a picture, so I guess there isn't anything for me to draw. So how am I supposed to figure out my setup? They're going to describe the setup to you. They told you that they are complementary. So think back on our notes, these right here. What is complementary? Complementary are two angles whose measure add up to 90. And we have this right here, this setup. If it's complementary, blank plus blank equals to 90. That right there is going to be a new setup. So I know you don't have that much space. So right here at the top, maybe you have a little bit more. We're going to add some examples of more setups for angles. Angles are a little bit trickier than segments because we don't have all these extra rules. We do have all these extra rules for angles. So complementary. And we're going to be looking at this setup right here for our complementary, okay? And then I would just do angle, let's just do angle plus angle equals to 90. Angle blah, 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 blah. So I just put little scribbles plus angle blah, 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 blah equals to 90 degrees. So with this one right here, they're telling you it's complementary. So they're telling you that when you add these two things together, it's going to be 90 degrees. Measure of angle A plus the measure of angle B is equal to 90 degrees. And then just replace. So A is 3x plus 7 plus Measure of angle B is 6x plus 11 equals to 90. And then you would solve this one. So let me just do that real quick. Go ahead and first things first, distribute. No distribution. Second step, combine like terms. We have like terms. 3x and 6x is 9x. And then I have positive 7 and positive 11, which is 18, equals to, and then 90. We're going to go ahead and I'm going to go over here at the top because I ran out of room. We're going to get rid of that 18 on both sides. When I do that, that is 72 over here, 9x. And then we're going to divide by 9 on both sides. X equals to 8. Now, for this one, it says determine the measure of each angle. So I do want to know which each of these angles are. So let's do measure of angle A. And we have 3x plus 7. So 3, and then x is your 8. So 8 times 8 plus 7. 3 times 8 is going to be 24. And then you're going to add 7 to 24. That's going to be 31. Now, you can do the other one if you want, but remember what your rule was at the very beginning. These are complementary, so they have to add up to 90. So I can also do 90 minus 31, and you're going to get 59. Angle B should be 59, but we can always go ahead and do it. Angle B is 6 times 8 plus 11. 6 times 8 is 48. Adding 11 to that is going to be 59. Now, if you would add these two together, 31 plus 59 is 90. So that's literally what we did over here. And that's literally the definition of what they told us it was going to be. Okay? All right, next one. This one right here in the diagram to the left. And sometimes they don't say that they're complementary, and instead they give you a picture. So if I give you a picture right here, so for this one right here, keep in mind that right now they told you it was complementary. Maybe on your quiz or on your test, instead of saying it, they'll give you a picture that looks like this, okay? Keep that in mind. You have an example of that in your notes right here as well. You have that picture right here, okay? All right, take a look at the next one, and hopefully we're kind of, so sorry about that. So hopefully you're kind of able to see the setup for the next one. This next one right here, we have this angle right here and this angle right here. Now for these angles right here, these are linear pairs. And linear pairs are supplementary. Supplementary means they add up to 180. So very similar to the one that we just did. These right here add up to 180 degrees. So the first angle plus the second angle equals to 180 degrees. We're going to add that to our cheat sheet right here. Supplementary. I'm not going to spell all of it. Angle blah, 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 plus angle blah, 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 blah equals to 180. It's one that I want you to keep in mind. Okay. I'm going to work this one out real quick. Let's combine like terms. 68, that's 166. So 5x plus 166 equals to 180. We're going to subtract 166 from both sides. This is 5. Oh, so sorry. I just noticed I made a mistake. This should have been 9x. Let's try this again. We have 5x plus 68, and then we have, this is 9x. I don't know why I put 9d8. Equals to 180. Okay, let's try that again. 5x and 9x is going to be 14x plus 68 equals to 180. 180, we're going to go ahead and subtract 68 on both sides. 14x equals to 112. To get the x by itself, we are going to divide by 14. X equals to 112 divided by 14, which is 8. Now, again, determine the measure of angle CEB. So CEB, if you're like, well, why are they asking me for CEB? That's not even any of the ones that they gave me in the question originally. But we've already talked about this type of angle as well. This right here is a vertical angle. So whatever you get here will be the same thing as what you get here. Okay, let's write a note for ourselves. These two are vertical angles. Okay, so I'm going to go ahead and substitute it into that 5x plus 68. So 5x plus 68. So that would be 108. And that is the measure of that angle right there. Let's add that one, and this will be the last one that we add into our cheat sheet. Vertical angles. And we'll add pictures in a second, okay? Vertical angles, the angles are just equal to each other, okay? So complementary, remember they're going to look like this. A right angle. Supplementary are going to look like this with that linear pair. Or they're going to say it in your question. And vertical angles are going to look like this. If you want to color code them, go ahead. This is what your cheat sheet should look like for angles. I will say it's a lot more for sure than segments, okay? It's a lot more to think about, okay? So as you're working with your questions, these right here at the top are really, like, I'm going to tell you complementary, supplementary, vertical. Or you're going to notice, oh, the question doesn't have bisector in it. Or you don't have all the pieces. This one right here, you will see that they are going to look like these right here, these pictures right here. Either a right angle, 180-degree angle, or it's going to be two lines that intersect like this vertical angle right here, okay? And we are actually going to stop right there. Make sure you're studying these and looking over them. Color code all of your things. I know it doesn't seem like it's very helpful now, but it will be when you are working on your quiz and studying for your test, okay? Good luck.